Hello and welcome back to the Oxford MAT Livestream. My name's James and today, integration and differentiation. Hello to everyone who's joined us over at slido.com. Great to see you over there. Let's run the poll for how was your day today. That's on screen. There we go. And hi to people who have already been hanging out beforehand, asking questions. One of them is, am I able to score over 80 marks in the maths by just watching this going on series? And I guess my answer to that question is let's find out. I recommend that as well as watching this going on series, you might like to try some of the questions or even some past paper questions. You might like to reflect on the maths that you're learning and just generally practice. Plus also, another thing you'll need to do if you want to score over 80 in maths is register for the test. I'm going to say this every week, I'm afraid. There's a thing called registration which you need to do in order to take the test. Step 0 is to start a UCAS application so that you get an ID. And then step 1 is to register in the future. In one of these episodes in a few weeks' time, I'm going to start saying, and now also book a slot at a test centre. So we will get there when we get there. Good, and hi to Owen, who is helping out in chat. Owen's a current student, they've been helping out for a couple of weeks now. Hi to Owen, and yes, good. Right, okay, poll, how's that going? People are having a pretty good day, like 4.3. That's pretty good. No one's voted 1 star or 2 star yet. Maybe now that I've said that, people will vote 1 star or 2 star. Let's hope not. Right, good. Sorry, Slido has changed something. I think it might be AI or something. It's now highlighting chat messages without me asking it to. So that's fun. YouTube has changed. I don't think that's AI. Everything's a little bit different. Right, good. Okay. How are you doing? Let us know in chat as well. Hi to, I can see Anonymous, TUC. Loads of people joining in on Slido. Nice, good. Okay. If you've seen the previous couple of episodes, you know the plan. We're going to talk about the MAT syllabus. We're going to look at some revision notes very quickly. We're going to get stuck into some revision questions, and then from about 6 o'clock or maybe a bit before, we're going to switch to talking about past MAT questions. I'm mostly focusing on stuff from the worksheet. If you want to get a copy of the worksheet that's at the top of the screen there, irritatingly just behind the poll, if you want a copy of that, you can get that and so much more on the MAT Livestream homepage, which is www.maths, which is short for mathematics.ox, which is short for oxford.ac, which is short for academic.uk, which is short for United Kingdom, /r, which is short for redirect, /MATLIVE, which is short for MAT Livestream. And if you can remember all of those abbreviations, then you can find the worksheet. There's also a link in the YouTube description if you're on desktop and want to click a link. Hello everyone. Right, good, okay. People are having a 4.2 star day, which is not actually that good by our standards. A space for 0.8 stars worth of maths-based day improvement, I think, which is my phrase for improving your day by doing some maths. Sam's doing year 13 content. Good, sounds fun. Ned wants other ways to prepare. I always recommend any tricky maths problems that you can't do straight away. So anything you get stuck on. Because being stuck is the thing that you're trying to practice. Well, I suppose getting unstuck is the thing that you would like to practice. But the only way to practice getting unstuck is to practice being stuck. Let's see what happens in between. So for Ned, I'm going to recommend things like other tricky maths problems that you might be aware of. There's something called STEP, which is used by other universities. There's something like TMUA, which you're aware of, which is used by other universities. But let's go a little bit wider. There's also AEA, which is a maths exam. I think now either a much reduced one or an obsolete one, I can't remember, but AEA is another maths exam with tricky questions. I like the Enrich website, which has maths problems and exercises and games, but you have to ignore all of the suggested age ranges, and basically like anything, right? There's loads of acronyms and maths competitions and challenges which you might or might not be interested in, where the thing I'd like is if you can find some questions you can't do straight away. What else is in there? Chat says, what's the minimum you need to score in the MAT to get selected for the interview? What was it last year? There's actually no minimum. There's no hard cut-off mark. It's not a pass-fail sort of thing. The MAT score is really important, but it's not the only thing we look at. We have shortlisted for people for interview without a MAT score, or if there's some reason why they couldn't take the test. So I suppose numerical answer to your question is probably 0. But let's not live as if the threshold is 0. It's no threshold. Okay, we have guidance for tutors based on MAT score. In general, the higher your MAT score, the better. Right, what does calc mean? If somebody says calc, they probably mean short for calculus, as in integration and differentiation, or they maybe mean a particular test taken by people in the US on calculus. I don't know why I don't know why I added that second case, Tom Clancy. Just thought you'd like it. Oh, right, in longer response MAT questions, we haven't talked about these at all yet, have we? We've seen a couple of examples, but for the long questions on the MAT, they've got separate parts, and you get marks for, well, often they'll ask you to explain or justify something, and you get marks for your explanation or justification. So there might be a numerical answer, which might be worth 1 mark perhaps at the end, but some of the marks are there for your explanation. So often we use those long questions to ask people why something's true, and then just stating that it's true is not what the question says. The question is why is this true? I'm just looking to see if we've got any good examples coming up later today. I think we'll do some maths in that kind of style, if you like. On the revision problems, I can see somewhere there's a deduce that and there's a show that. So we talk about that style of mathematics, right? You get partial credits. Good. Okay. Can I get over 18 just by watching this going on series? Yeah, there you go again. Is my microphone on? I think my microphone's on. I think we're good. Yeah, I think I'm live. Yeah, I think I'm live, and I think my microphone's unmuted. I think I already answered that question. Good. Yeah, and then are they going to be just logic? I wouldn't advise you to expect just logic. You can look at the ones from 2024, for example, and I wouldn't describe those as just logic. But you don't need to be able to type special math symbols. We're expecting people to use a normal keyboard because that's what we're giving you, and we're expecting people to use a normal keyboard in a normal way. It's not really a keyboard exam. It's not how good are you at typesetting mathematics. So the questions are designed so that you can answer them using words and basic symbols like the ones that are on a normal keyboard. Good. Okay, I think the going on series question has been asked too many times now. That will do. Right. Okay. Yeah, thank you, Anonymous. You can hear me, but somehow the question keeps coming in. Right, good. Okay. I'm also ignoring the why question. Sorry, just no comment. Like the fact is that they're not being released, and I'm not going to discuss why or why not. Okay, good. Let's do some integration and differentiation, shall we? Let's just switch chat. I can still see chat on my other screen, but let's get it off the screen for a little bit there. Okay, right. To exit full screen. No, I like full screen. Thank you very much. Okay, I've got the syllabus at the top, which explains quite tersely what sort of maths we're expecting people to know at the time of the math submissions test, which is probably not all of the integration and differentiation that you personally know. You probably know other stuff. So you can rest on your laurels, I guess, and look smugly at this list of maths and think, I know other things like the chain rule, or maybe partial fractions, or the product rule, or the quotient thing, or whatever else it is that you know. But there is information for you here, even if you know other stuff. Something I want you to notice is that the test is designed so that you only need to know these things. That's information, because even if you know the double sandwich lemma or something mad, then the questions are written so that we're not expecting people to know the double sandwich lemma. And let's rephrase that for the question we had before. If you know how to type the symbol for the double sandwich lemma, then, well, good for you, but the question is designed so that you won't need to know how to type the symbol for the double sandwich lemma, because you won't be expected to use the double sandwich lemma. You can read that in two ways, right? You can say, in one sense, if you know other maths, then, hey, maybe you will be able to use it, but maybe not, because the questions are being designed so that you won't do that. Right, okay. That's the kind of question awareness thing as well. When we're looking at questions later on, the kind of toolkit that you need doesn't include some of the things you might have seen. The reason for this, by the way, is that some people are learning maths and further maths A-levels in parallel, and some people are learning maths and further maths A-levels in series, which means that the second half of A-level maths. We don't know if you've seen it or not. We know that by the time you get to university, you will have seen it if you're doing A-levels, but we don't know if you've seen it yet or not. So there's all this maths that you might already have seen, especially if you did A-level maths just now at the end of year 12. All this other maths you might have seen, but you might be interested to know that that's not on the maths syllabus. So it's not involved in the questions. Good, okay. I'm trying to do a sort of meta-knowledge thing here. Meta-knowledge is knowing what you know. That's maybe too much, isn't it? Do you need to know the formula for differentiation from first principles? Depends what you mean. I've got something, so further down, I've got more notes, and I've got a bullet point about integration by first principles that I want to put on the screen. I think I'm going to do that now. If you're thinking about limits, you're not expected to know about limits. So if you've done some sort of introduction to limits, you're not expected to know that notation or those symbols. And there's a tiny bit of integration so there's a request in chat for a tiny bit of integration from scratch. Let's look at the first bullet point, and then I'm going to point you to where you can get the rest of the bullet points as well. And an international student asks, am I eligible, but I don't have the A-level. Well, look, we've got lots of international qualifications. I'm going to keep saying A-level or equivalent, and whenever I say A-level or equivalent, there's a bit of our website called International Qualifications on the Oxford website that's got a list of international qualifications that we accept. We do need certain qualifications equivalent to A-levels. Good, okay. For baccalaureate qualifications, that might be like some overall baccalaureate with scores in various things. We've tried to make it equivalent to our A-level offer. So we've got people from different backgrounds, different exams, but doing similar things to a similar standard. How do I want to play this? I think I want this. Let's go like this, just for quite a lot of revision material all at once. Here we are. So for the person who asked for integration from scratch, I think what I need you to know is a rule about how to, let's start with differentiation, how to differentiate, and some idea that this gives you the gradient of a curve. So I've got on the screen at the moment, I've got information about finding this kind of tangent line, this idea that the tangent line is supposed to have the same gradient and the same value. This is the idea that given a curve, you can draw a line that's just tangent at that point with the same value, same up and down y value, and the same gradient. We had this a tiny bit last week when we looked at a graph and we had a line that was tangent at that point. There's a way to work out, given a curve of a particular form, there's a way to work out how steep that gradient should be. And that rule is that first bullet point, which says if your function is x to the power of a for some number a, then the rule for how steep that curve is well, it depends on x because it's different gradients in different places. It's the joy of a curve rather than a straight line, different gradients in different places. And the rule is that the gradient is a times x to the power of a minus 1. That's quite nice. Easy to remember. You bring down the a and you subtract 1 from the power. That's about it. So I need some understanding of what the gradient tells you, what the derivative tells you, and I need you to be able to calculate it for powers of x and for exponentials. And those are the things that I'm assuming. Yeah, okay. I see the questions in chat. I will do these in a second. If you want to know more cases or sort of other examples of what you might do with this information, so what's the normal to a curve, for example, or what if you have a sum of two functions, or some, say you want to deal with a polynomial, and the other thing I need you to be able to differentiate is an exponential function. But that's kind of all I need you to be able to differentiate. There's a bullet point here about first principles. It's this second one down here. I think I'll go back to the split screen for this. So this is idea on screen. Let's just put it, there we go. Perfect. To say, if you have 2 points on a graph, so I'm going to try and draw some nice curve on my graph like this. Have I done that well? I'm not sure I've done that very well. I'm going to do a slightly different one. Reset. I want something with a bit more curve to it. Yeah, imagine it first and then draw it. Beautiful, nice and steep over that. Then you can do something where you take a point A and a point B. So first point and second point, you can draw a line between them, and I'm going to extend it out. So I'm going to extend out the line through A and B. And then the thing to imagine is what happens if you keep the point A fixed but move the point B really close to the point A. So if I move B to be over here instead, then I'll get this line, which has got kind of the same slope to it as a curve does. The curve does, just nearby to A. I mean, A is its curve, the gradient changes everywhere, but if I take 2 points that are really close together, then I get a good measure of what the local rate of change is just here. That's kind of the only picture I need you to have in mind for differentiation from first principles. Whoops. So it's this first principles thing. And because you know a formula for how steep a straight line is, this kind of gives you some idea about what the gradient should be of the curve nearby. I've written down this formula y2 minus y1 over x2 minus x1, which you've hopefully seen for the gradient of a straight line. And there's maybe an idea that as you get close, that should be the same as the gradient of this curve nearby. Right, let's quickly go through chat. Here we go. I'm going to put chat on screen very quickly, just so we get that going again. People are sharing where they're from. Let's go down here. So just to check, can we be asked about continuity and differentiability of functions? No, I don't even need you to know what those words mean. They're not on the syllabus. Yeah, continuous and differentiable are not words that are on the MAT syllabus, so you can't be asked questions about them. And when typing for the exam, will we need to know how to use LaTeX? No. We would really have to tell you, by the way. If we expected you to know LaTeX, oh my goodness, I would have to do like so much work to teach you LaTeX. It would be completely unfair for me to assume that teenagers everywhere know how to use LaTeX. This question is essentially, is your exam evil? Are you failing to prepare me for this? Like, no. The questions are specially written so that you can answer them even if you don't know how to type the sandwich lemma symbol. Right. And then what's this about integration? When you integrate, do you always get the area? That's a good question. Let's draw some pictures. Which bullet point do I want on screen for this? Yeah, I think I want this one down here, don't I? So if you want these notes, by the way, I'm scrolling at random up and down, which maybe is annoying. But if you want to grab them, they are on the MAT Live page. There's this idea that areas are supposed to be positive, which is the convention used by the math submissions test. So I can say that if you've got f of x, I always draw my functions like that. I don't know what, that's my generic shape for a function, I suppose. And here's the x-axis over here. So if f of x is positive, everywhere or maybe just in this region, between a and b, then when you integrate f of x from a to b, which is the integral I've written down there, you get the area between the curve and the x-axis and the lines x equals a and x equals b. We might describe that as the region bounded by x equals a, x equals b, the x-axis, and the curve y equals f of x. Let's put all that in as well. Y-axis as well, for completeness. That's one case, but the convention used by the math submissions test is that areas are positive. And if you just integrate a function that's negative, I should give this one a different name. I'm going to call this one g of x. If you integrate a function that's negative, then you'll get a negative number. Areas are supposed to be positive. But not all is lost, because you can multiply by -1 and you'll get a positive number. Good news, that positive number is the area of the shaded region. Okay, why do we only get a negative integral when the curve is below the x-axis, when y is negative? Yeah, so it's sort of magic, isn't it? If you integrate a negative function, you get a negative answer. That sounds silly, but I suppose it's not obvious that when you integrate, you get something like that. I suppose I can only justify that if I start explaining where the rule for differentiation and integration comes from. And that's really a university thing. In order to understand, this very first bullet point I showed you right at the top, that the derivative of x to the a is a times x to the a minus 1, you get all the way through A level or equivalent I think without ever being told why that's true, which is kind of mad. If you'd like to know why it's true, then I strongly recommend doing maths at university, because we'll tell you where it comes from. And along the way, you will learn why integrating a negative function gives you a negative number. Yeah, if you like, we take the modulus. Although, think about what you're doing as well. There's a chat comment that says, so we always take the modulus. Let's think about what we're doing. I think a question on this would have to be quite carefully worded, otherwise it would just be a mess. But what would I mean if I had a function? I'm going to call this one h of x. I'm going to run out of letters before the end of this live stream. What would we get if we integrated from a to b in this case? So I kind of started like this, but then ended up like that. So if we just integrate, we get some positive contribution from this bit, and then we get some negative contribution from this bit, where the function is negative. What do I mean by contribution? Well, I suppose what I mean is something like you have two areas here, area A1, and over here, area A2. Obviously, if your function crosses the x-axis more times, then you'll have more and more of these areas. It could be quite hard. And for this one, the integral from h of x dx is equal to a1 minus a2, which looks awful, but really this is because this is a problem with how we define area. If you insist that areas are going to be positive numbers, then integration kind of doesn't know that. Integration will give you just what it can see: positive things, negative things. Positive where the function is positive, and negative where the function is negative. So the integral will give you a kind of positive amount minus positive bit corresponding to that area. Yeah, so you can split it up. If you want to think about this, you can split it up by putting in a number c for this part here, and then applying the two things we were talking about before. This first bit, the integral from a to c, is a1, not controversial, and then the integral from c to b is minus a2. So that's why I've got this minus sign in here. I'm not quite sure what the question would be here. It would have to be worded quite carefully. And the reason I've drawn this is just to say, if your rule is just put a modulus sign on it, then you can run into trouble with things like this, where that's not really a mod sign, that's a minus sign on some of it. Split it up. Or if you're happy, you could turn this bit upside down first if you want to do that, but probably you want to find that point. Good. Okay. Yeah. So Ruben in chat, if you want to read, let's put this, has put an explanation of integration from first principles to do with adding together infinitesimal rectangles, which I'm not going to read out because I want to highlight the idea that this is not on the math syllabus. You're not expected to know that integration is about adding together infinitesimal rectangles. You're not even expected to know what an infinitesimal rectangle is. There you go. Right. In the curve you just drew, I'd get a different answer by integrating h of x versus finding the area between the h of x and the x-axis. Yes. So if you want the area, if this thing is like a nice design for a bow tie that I'm going to go and make, then probably the question I want to ask is, what's the total area of these regions? Both sides of the bow tie. In which case, probably what I want is something like a1 plus a2. I want to add the areas together. Whereas integration doesn't really do that. Integration sees that this bit is positive, and integration returns a negative number for this bit because it's under the x-axis. This is quite bad. So this is kind of, either you could think of this as a problem with how integration works, that it returns negative numbers sometimes. Or you can think of this as a problem with how area works. And I've been saying the convention for maths admissions test is that areas are always positive. Some people take the not for MAT, but some people take the opinion that areas should be allowed to be negative. I've been shading areas in different directions, that way for positive and that way for negative, but you're not required to think about that at all. Just thought I'd say it in case it made anybody happier. We got a 4.2. We've got to get that 4.2 up to a 5. Do you need to know integration by parts? Asks chat. Great answer. No, it's not on the syllabus. You don't need to know it. Even better, right? It's not on the syllabus means the questions must be written to be fair to people who don't know integration by parts, right? Which means not only do you not need to know integration by parts, it kind of also means that you won't be able to use integration by parts in a profitable manner. Maybe not. Who knows? Okay. Right. Ginger Biscuit knows Green's theorem, which, let's be clear, is not on that syllabus, but does deal with negative areas, which I think is why they've shouted it. Yeah. So the things used to be, we used to have things like the trapezium rule on the MAT syllabus in the olden days, 2016. If you look at past MAT questions, you might find that they were based on previous A-level specifications, where many years ago people would learn about all these facts about trapeziums. They're not very difficult facts, but they're not in the MAT syllabus anymore. So we change these things gradually over time as A-levels change. One day somebody will invent some brand new mathematics that will eventually make it onto the A-level syllabus, and then we'll be able to ask MAT questions about it in the distant future. Right. I don't know if this is confusing or not. I sort of think it might be confusing. This feels like the sort of thing that people find confusing. So I'll say one more thing, I think, which is a question on this would have to be very carefully worded to make it clear what's going on. And you should, if in doubt, remember that areas are positive. And I love this idea about splitting up integrals to do them bit by bit, which is usually quite good. Okay, what was the 6, 7 part? I didn't quite catch it. What did I say about 6s and 7s? Oh, I don't know. Good, okay. You also don't need about trig substitutions or substitutions. This is great, isn't it? People know loads of maths. I tried to foreshadow it at the front, but people know loads about integration that's not on the maths syllabus. Great news. There's actually a list right at the top of the doc. It's not a secret. There's a list all the way up here. That's it. That's the maths syllabus. There isn't like secret knowledge. That's the maths syllabus. That's the sort of maths that we need you to know about integration and differentiation. That's the game we're playing here. There you go. Right. Okay. Right. Having showed you this area fact, I want to, I think, get everyone nice and confused by talking about this fact about the area between curves. This came up a couple of weeks ago, or maybe it was last week. Goodness me. To think about the area between f of x and a line. So given some function f, so think about the area between a curve and a line. I want to quickly justify what's going on here. And the discussion we had before was around whether or not the x-axis matters. So there's this complicated case at the bottom here with two different bits of area shaded. That's the same problem that we were just looking at. That if you care about area, the thing you probably care about is the total positive area of these different regions added together. And awkwardly, that's not quite what integration gives you. Integration will subtract if you give it negative numbers. So awkwardly, that's not quite what we want. But let's talk about let's talk about the easier case first, which looks like this. So in the easier case first, nothing to do with the x-axis. I just want to talk about having a function. I'm going to draw the same shape again, f of x, and a straight line y equals mx plus c. I'm going to say that this is y equals f of x. There we go, good. I've got a y-axis over here somewhere, and I promise you I have an x-axis, but it's just down here. It's like only slightly relevant. There we go. So if we want the area between the curve and the line, There we go. Just geometrically, there are some tricks we can do if we want this area. Because if we integrate f of x, that will give us not quite the area we want, it will include this bit as well underneath the line. Because if we just integrate f of x, it doesn't know about the line. So the integral of f of x from, let's say it's a and b again. A and b, slight zoom out, there we go. That includes r. But the integral of mx plus c is the area of region R. So all we need to do is a bit of subtraction, just geometrically. This region that I'm interested in, between the curve and the line, is everything under the curve minus everything under the line. Which sounds quite nice, right? And this is a good way to think about it. But this thing is the area of R. And I think this is a good thing to have in mind, except that if you have only this in mind, then you'll get quite worried about the role the x-axis plays, right? Because if the x-axis is higher up, then the thing we were just saying is that integrating f of x might or might not give you the area underneath. Everything's fine though, and the formula I've got up there is correct. Even if the x-axis is somewhere in between, somewhere in play. What I said last week, I think, is the easiest way to see this is to take your region with the x-axis going right through the middle, and to just translate everything up a bit. To imagine adding a new constant. We've used a, b, and c, so let's say the new constant is d. Let's imagine adding a constant d to both of these things. And now that'll move them up. So if the x-axis was worrying you before, that'll move both of them up again. But it'll appear in both of these. So when I do the subtraction, it will cancel out. So if you like, translating the area upwards doesn't change the size of that area. It might change like fiddly details about how we calculate it with integration, but if we move it high enough, then integrating this thing up there will be just like this. The x-axis will be far away below, and we can safely do this kind of area minus the area of region R. That's a way of justifying that the answer at the end is still that formula up there, f of x minus mx plus c, that difference. Yes, right, okay. Would that work for, yeah, so then in chat somebody says, would that work for f of x a cubic and g of x a quadratic? I think the answer is yes. There's nothing special about a straight line, right? If you're happy with this argument, then maybe you'd be happy with any two curves, f of x and g of x. In the notes up there I've got a curve and a straight line, but with a bit of ingenuity. Maybe you just accept a version of this argument with f of x and g of x, if you're given two curves, or with a bit of ingenuity, maybe you can apply this to say, if I have f of x and g of x, then I could draw a line between them and use this factor twice. If you do that, then you end up with the same answer. So it's kind of good news. Ideally, you have functions that don't overlap, or a function and a line that don't overlap. This is my case. How have I described this on screen? Sorry, the text on screen is really, really small for me. Weirdly, it's easier for you to read than it is for me to read, even though I'm right here. It's like bigger than my head and I can't read it. Yes, I've said if f of x is greater than mx plus c. There's a similar thing here around if the curve and the line intersect, then you might need to split it up into regions, which is this diagram here. This idea that if the curve crosses the line, then you've got some bits where integrating the difference will give you positive numbers because the difference is positive. And you'll get some bits where integrating the difference would give you negative numbers because the difference is negative. Watch out for that, because integration will give you negative numbers, and it will give you, negative in some region if you let it. And if you only care about areas and the sum of positive areas, then you should watch your integration like a hawk to try and make sure, watch it really carefully to check that you're getting positive bits of area everywhere. Right, good. Somebody in chat has said that was helpful, which is... Okay. Right, so anonymous, let me catch up with chat very quickly. Does this work even if fx is not above g of x across the entire graph? I'll say no. The picture here is the same sort of case. Should we draw this f of x, g of x? I thought it would be too complicated for the revision notes, so I didn't put it up there. But I think the thing people are describing is, what if I've got f of x, and also g of x? That's a much better picture of a bow tie. I should do those in different colours, really. Too late now. If you look really carefully, then in this region, f of x is greater than g of x. So if I want this area, I should integrate something positive. Watching my integration carefully, I should integrate something positive. I will integrate f of x minus g of x. I want for the area. And over here, g of x is greater than f of x, so same thing the other way around. I'm going to put in some x values in a second, just to be clear. Well, no, I'll just put arrows. I apologise for this already, but I love putting arrows on things. Maybe I can fix this. A, B, C. A, B, B, C, maybe. Is that helpful? I don't know. You saw me draw it, so labelling it afterwards is not that helpful. Two anonymous people simultaneously. One of them says was confused before, and one of them says I'm confused now. So it's one more bit. This f of x, g of x stuff is a bit more complicated than I was planning to say today. What I'd like you to think about first is this idea that if you have f of x definitely larger than mx plus c, then integrating the difference gives you this area in between. If you're okay with that, then you can generalize, but I want you to understand that first. So if that's new or confusing, then I'd like you to go and, I guess, get to grips with, pick some numbers, pick a function. Pick a function that's definitely larger than a straight line between a and b. So maybe you'll choose 2x plus 1 as your straight line. I'm going to get rid of these plus d for a second while I point at this. Maybe you'll pick some really large quadratic expression and some straight line, and I'll let you to go and calculate both integrals, and convince yourself that finding the difference is a reasonable thing for the area in between. Maybe you could draw them on graph paper and count how many squares there are in between to convince yourself that that difference really does work. And it should work because it's sort of the area under f minus the area under the line. And there are some other different cases, but they're not really too different. And part of my argument here is that for this sort of thing, the difference between a curve and a line, where you know the curve is greater than the line, you just need to do the difference. If you found all of that unconfusing, then I'd like you to check that if I replace m with the number 0 and c with the number 0, then this becomes the x-axis, right? So if this is the curve, if this is the line y equals 0, or if g of x is the 0 function that always returns 0, then it is now the x-axis. And there is a combination here of things that I've told you not to worry about for mx plus c, and things I have told you to worry about for the x-axis. And I'd like you to check in your head that if m is 0 and c is 0, then all of the things you might worry about for that case turn precisely into the things that you would have worried about for just the area under f of x relative to the x-axis. And if you like, all we've done here is generalize from the 0 case, straight line, x-axis for the second function, generalize that nicely to straight line or even function. Right, here we go. It's a popular question in chat, but let's answer it once more. Do we need to know derivatives of trig functions? No. The product rule? No. The quotient rule? No. The chain rule? No. Integration by parts? No. Integration by substitution? No. There you go. I like that question quite a lot, actually. I get to say no, no, no. You don't need to know them. I mean, for your personal life and your general education, I would encourage you to know them if you have the opportunity to know them. But for the maths admissions test, we don't know whether you've learned them or not. And there are other people doing this test who haven't learned them yet. So the questions are written so that they're fair on those people, that even though you know integration by everything and they don't, the questions are written so that both of you can have a go at the question. Aha! Right, anonymous in red or purple or whatever colour that is having a go at the question about second function. Good, right, okay. We added this picture this year to the notes. We do make small changes year on year to the MAT Livestream. I think this was a successful change because we got something to think about, which is nice. Right, should we do some revision questions? We usually do, don't we? Let's do some revision questions. Like normal, there's a poll for you to vote on which ones you want to do. Let's put some of them on screen. So I'm actually going to turn off chat so that it's not on top of the questions while we're looking at the questions. And I'm going to have a look at the questions now. There you go. So here are some. If you would like to try all of these, you can get all of them on that live stream. And any of them that we don't talk about, you can get solutions for. That's not a necessary condition. All of them have solutions also on there. There's a solutions document, which might make you think, what's the point of the live stream? You've already published the questions and the answers. Why are we doing this? The idea is that I would like to talk about some of them. I'd like to talk about whichever ones chat picks. Let's say power over to chat right now. They're voting for what we're going to talk about. I'm making notes. Well, I'll let them vote for a second. Right. Quick breather. How's chat doing? Is a UKMT good prep for math? It is, and it is, and it isn't. UKMT has lots of problem-solving stuff where you practice getting stuck. Doesn't have any integration. So if you only did UKMT stuff and didn't go to classroom stuff, didn't do any A-level stuff, then I don't know whether you'd learn integration. So in some sense, the content is different, but problem-solving's there. Yeah. People are talking about Desmos. I don't know why. Desmos has made some changes. They now let you save graphs. Sorry, this is a breather for me while the voting's happening. If you're looking at the questions on screen and you think something looks interesting, you can vote in Slido. Here are some more. The last ones are a bit longer. Look, there's one of these show that questions, right? What does it say? What does it say? What does it say? Prove that I1 equals I2 by considering a rescaling of the graph. That one probably couldn't be a MAT question because I think that one is too close to integration by substitution. Although that one, if we do that one, we will talk about how to do it without using integration by substitution. The questions are fair. The revision questions, in case anyone hasn't noticed, they're not MAT questions, and they're also, well, they're just written. Lots of them are just written by me, and not always to the same standard as a MAT question, or playing by the same rules as a MAT question. Some of them are written partly to just make you think in a way that wouldn't actually be very good for a test. One of them's quite open-ended. Yeah, 13 is a bit weird. Right, let's have a look at the vote. Let's see how they're doing. They voted for 11, 12, 13. 11 and 12 are currently tied, so that's fun. And a little bit of 10. And then 7, which is interesting to me. Yeah, 7 is the integration, 7 is differentiation from first principles, so it kind of makes sense. That's a topic we talked about a bit. It looks like 11, 12, 13, 10, and then hop back to 7. What have I got? It's 5:45. Let's see. Does it matter how simplified the answer is? Depends what we're talking about. For a multiple choice question, you've got to simplify it enough to match one of the options, I suppose. I mean, in some sense, there's no right answer to this. This is a chat question about how much do you have to simplify your answers. Is 13 a use up? Oh goodness me! Do not do a substitution on question 13. Oh my goodness! Right, okay, let's avoid that. There's a challenge here, right? For this person at the top. Oh my goodness, we're 2 down. Sorry. They have this danger now, right? That they know integration by substitution, which means that they are a bit of a disaster. They're going to try and use that on question 13. Let's talk about 11, 12, 13, shall we? Do you take the interviews? Yeah, I do some interviews. There's about 100 of us who do interviews for maths at Oxford. It's a big team. It's basically almost everyone involved in teaching is probably also involved in interviewing at some point. There's a load of us. Good. Right, ginger biscuit. I think I know what you're doing. Right, okay. I'm not sure it's helpful. Right, okay. Was it 11 first? It's 11 first. Here we go. So 11, well, I thought this would be fun. This is asking you about the area under a curve. And I thought it'd be fun to think about rescalings of the graph of y equals 1 over x, right? So, oh, I've changed all my zoom settings. There we go. I thought it'd be fun to talk about the graph rescalings of y equals 1 over x because maybe you noticed the range of integration there is 1 out to 10 and then 10 out to 100, which is kind of weird. And the thing that's happened there is that the values of x have been multiplied by 10. Arrows, again, I love arrows. So, question, if you multiply the values of x by 10, what happens to the values of y that you get over there? I suppose you make x 10 times larger. This is inverse proportion, isn't it? So it says if you make x 10 times larger, y will be 1/10 as large. So that means that each bit of this curve over here, you can do a rescaling where you multiply the x values by 10 and you divide the y value by 10, and everything moves over from this region over, so somewhere over here. So if I move if I move x to 10 times as much, I'm going to write that like this: x goes to 10 times x, and y goes to 1/10 of y. Then, I mean, for example, the point 2, 1/2, which is somewhere over here, goes to 20, 1 over 20, which is on the curve, because I did it correctly to move on the curve. Also, everything underneath the curve goes to things underneath the curve. But there's another fact, right? That area is okay by this. If you stretch by a factor of 10 one way and you squash by a factor of 10 the other way, then a little square or rectangle or anything will get stretched out just as much as it's squashed. So if you have a rectangle and you make it 10 times wider but a 1/10 as tall, then its area is the same. So it's supposed to justify the idea that these regions have the same area, which is of course what you're trying to justify. So you can use this kind of rescaling thing to say, aha, the area has just been stretched and squashed. But if you stretch and squash an area, then it's like, I don't know, you're working with dough or something. You've got your Play-Doh out and you stretch it, it squashes. You've still got the same amount of Play-Doh, but now it's much wider and squashed down. 10 times wider and 1/10 as tall. Good. So that's my justification anyway. I don't know how I'd write that down for a test question. That's why this is a bit of a weird question. But you can do these transformations from the area. We'll talk about graph transformations next week, I think. But there are these ideas that if you stretch something, then you're making the area larger. If you squash it, then you're making the area smaller. And combinations of those things work together. You don't have to imagine the infinitesimal rectangles. The infinitesimal rectangles aren't real, they can't hurt you. Transforming the area is just a thing you can do. Right. And there's a question in chat that says, do you not need to know the U substitution? Look, I'm doing it without a U substitution. Okay, fine. There's this deduce part, which is supposed to be there as an example of a bit of natural thinking, problem solving, what's going on. You can make this integral from 1 to n really large. The idea I'm looking for there, and the reason I put this question up, was we can do that again. But once you've realised that the integral from 1 to 10 is the same as the integral from 10 to 100, the light bulb moment is to realise we can do that again. We can stretch it and squash it another time and get the integral from 100 out to 1000. And that will be the same again. Oh, the function's getting really small down here. It's got really stretched and really squashed. But this chunk here, well, before the interval was 9, then it was 90, and now it's 900. It's 10 times wider again, but the curve has been squashed by a factor of 10 on the way down. So that bit's got the same area. So you can make this arbitrarily large by including as many of these sections 10 to the power of k, as many of these as you like, and the areas will be the same and keep adding up. So you've got some area here, which I don't need you to be able to calculate, and then the same area again, so twice as much as you started with, then 3 times, then 4 times, then 5 times. Keep going as far as you like. You can keep going. Right, good. Somebody says, what is your job? I'm the admissions and outreach coordinator. I'm responsible for making sure that the maths admissions test gets set and marked. I'm in charge of looking after the content on the maths admissions test. And for the rest of the year, I get to do outreach things to tell people about maths, which includes telling people about the maths. So this part is the most visible part of my job because I'm online. And it's also both parts of my job because it's admissions, looking after that process, and it's outreach to tell people about it. I also do quite a lot of admin that you don't get to see, quite a lot of office-based things that make sure that things actually happen, but you don't get to see those. The stretch part is crucial, yes, good, okay. Right, okay, good. So that's 11. There was a request for 12 and 13 as well. Let's talk about 12 and 13. 12 and 13, I wanted to do this kind of abstract sort of question where you're told not to calculate the integrals, or in 12 you're explicitly told not to calculate them, and in 13 you're told to do it in terms of I3 and I4. So in a way that's like not doing it, because we're not going to work out I3 and I4. Maybe you know some maths to work out I3 and I4 in terms of arctan of 3, but maybe you don't. Either way, the thing I was hoping you might spot is that although these things are pretty nasty, they involve the same building blocks, right? There's a relationship between the things that we're integrating. Maybe you sketch the functions and they look pretty different, but algebraically, these involve the same things, right? This is 1 plus x squared, this is 1 plus x squared. Upstairs there's a 1 and an x squared. So I don't think this is obvious, but I think you might discover this if you play around with it algebraically, that if I want an integral I can do, I don't want 1 over 1 plus x squared, that's hard. I don't want x squared over 1 plus x squared, although, hang on, algebraically, can't I do something with this, right? When I see x squared over 1 plus x squared, I mean, that simplifies a little bit, because, well, you can do polynomial division or something, right? You can simplify this by saying that it's, and this will give the game away quite a lot, but let's leave that there, and let's leave that there. This thing inside, well, isn't that just 1 plus x squared over 1 plus x squared minus 1? Add a 1, subtract a 1. Sneaky plus 1 minus 1, which I've done on purpose because 1 plus x squared over 1 plus x squared, that's easy. That's just the number 1. So just algebraically, no sort of geometry or sketching or thinking about what these functions actually mean or what they look like. That's the integral of 1 from 1 to 3 minus the integral of this from 1 to 3. We've got a name for that second one. This is the number 2 and this is I3. So the fact is that both these functions, both these two numbers, I3 and I4, if you add them together, you get 2. Which I don't think is obvious, and I'm not sure it's useful. But the question asks us for a relationship between I3 and I4, and there's one. We can add them, yes. Yeah. So you can substitute. You can mess around with this one, or possibly you could have the light bulb moment of I3 and I4. I could bring them together and just add them, and then the numerators would join together. And it would just be the integral of 1 from 1 to 3. I love stuff like this because it's not some weird trick for how to do integration. Like actually calculating these values, totally different question. It's about resourcefulness, right? To say, if you know how to do I3, then you don't need any tricks to do I4. You should just do 2 minus the thing you already had. And I think sometimes people learn lots of tricks and they learn lots of, I should go and do a trigonometric substitution and I should use the double sandwich lemma and oh my goodness, it's going to be a whole page of work. When with a little bit of like resourcefulness, maybe you can spot, this is 2 minus the thing I already had. Do not just use tan x. There's someone in chat who wants to use tan x for a substitution. I think possibly they're trying to calculate I3, which is neither the point of the question nor particularly interesting to me right now. Let's talk about this one. It asks us to find the relationship between this and the stuff in the previous parts of the question. And at this stage we're on a roll, right? Things are going quite well, I'd say. We've got some relationship between 1 upstairs and x squared upstairs. And also the algebra that I did to try and simplify things, I'm pretty confident that that's going to work. Something like that might work here. Because, well, this is kind of x squared times the thing we had before, right? And you can't just multiply integrals together, but it's just more x's upstairs. So hang on a minute, can I just, I'll try the algebra again. But didn't we just decide that this x squared over 1 plus x squared is this? Just trying to copy out the algebra we just had. You know, there's an extra x squared now, fine. But then, well, before I would just integrate 1, and now there is this x squared here, which, of course, I'm going to get an x squared. But I'll also get something over here I recognise. So kind of just by spotting the difference between this and the previous thing, it's got an x squared out the front. And then using the same trick to rewrite x squared over 1 plus x squared. Well, this is turning into something familiar now, isn't it? You can just add I3 and I4. Let's chat. Oh, sorry, chat is talking about this. Yeah. So you can do this. You can subtract things. Oh, what do you want to subtract? Oh yeah, chat's got loads of questions. Okay. Let's put chat on screen because you're asking good questions. Kay says they did long division of polynomials. I don't know if I've done long division or not. I can't remember what long division means. Yeah, add and subtract 1 and then take difference of 2 squares. Oh, I like that a lot. That's really nice. Let's see that play out. Big fan of difference of 2 squares. Is that anonymous? Yeah, it is anonymous. That's a shame. I met a current student at one point. She said that she would switch between anonymous and her actual name. Her actual name when she was saying something funny she wanted credit for, and anonymous when she was saying maths that she wasn't 100% confident about. Sometimes I think that there are people in chat, anonymous and usernames, who can switch between. I have to remember this. Current student I met once. Although beware, because I think if you switch your username, it also switches it for past posts. So I think if I'm scrolling back, then I can start to de-anonymize if at any point you put your username in. You don't you don't have to use your actual name. Right, okay. I want to know about this subtraction that Rosie says, because I'm going to play this one out. Difference of 2 squares up here, recognizing that 1 is 1 to the power of 4. That's got to be a kind of all-time great thing to notice. Yeah, that's gone really well. Because then the x squared plus 1 cancels, and this bit is I3. That's really nice. Mine's going to involve I4, yours is going to involve I3, but of course those things are related because I3 and I4 add together to make 2. There's some requests in chat to go back and look at this bit. So I just want to tell people that, like, I suppose a different way to see this is if you've got these things, sorry about the noise there, if you've got these things, then you are allowed to add these together. There's no mention of any areas, we're just talking about the integration. And the integration behaves nicely. You can just add these things together. And maybe this is what you noticed. You can add these things together and then you get boop, boop. The numerators add up to the denominator. That's 1. That's the number 2. Oh, if you like it's the x 1 3 is 3 minus 1 is 2. But maybe I shouldn't shortcut anything, but I can shortcut some things. Oh, subtract I4 from x squared. Yes. In fact, that's what I've got. There we go. That's this, right? I think that's this. But you've recognised it the other way around, perhaps. I did some algebra starting here to work out where I go. Maybe you built things out of the things we already had. Nice. Divide x to the 4 by 1 plus x squared. ASAP says to get a polynomial and a rational function. Word problems. I think you're going to have to wait for I should be really snappy now and mention a different test that's all word problems. I think you're going to have to wait for a word live stream. Why can we multiply integrals? It's a good question, I suppose. counter questions are like, why should you be able to multiply integrals? There's this rule that you can add things together, so people have noticed you can add together the integrals, but you can't multiply. It doesn't work. It can fail quite badly. For example, the product can be 0, even if f and g are non-zero functions. So multiplication can go really quite wrong. That is not true. Let's put no before in case anyone takes a. I'm not even going to write the symbol to stop people taking screenshots. You can't split them apart like this. You can't multiply between your integral signs, even if all the limits match up. You can't move your products around like that. Can't the area be arbitrarily large if n were a large power of any number? Yes, true. If you make n large, you get an arbitrarily large answer. Yes. You can stretch by 2 if you like. The question is set up so that you might think of stretching by factors of 10, but there's nothing special about the number 10. You can use that one if you like. You could if you know about integration by parts, but it won't turn out to be this. Sorry. There was a request for 10, which is just talking about reflection. Maybe we'll think about this when we think about graph transformations. F of minus x gives you the same function, but reflected in the y-axis. So the integral will be the same because it represents the positive area underneath, or the area underneath. And there's a request for 7, which I think I'm going to point to the solution for 7. 7's talking about the way that the line between A and B gets really close to being the tangent at the point A, which I think in this case is 1, 4. So if you calculate the tangent at 1, 4, then this line gets more and more like the tangent at 1, 4. Right, okay. It's 6 o'clock, which means it's a good moment to remember that you're human. Blink, look away from the screen. If you've been watching the live stream for the last hour, then thanks. I hope you're enjoying all the integration so far. We're going to switch to doing math questions in a second. I'm going to pick one to start us off, I think. And then we'll go to chat for direction. I think I want to start us off by looking at 2018 question 1A, a very good place to start, which is this one about areas, because we've been talking about splitting up areas and finding areas between curves and lines, and this one's got the x-axis in there as well, so it's kind of like the super version of all the things we've been talking about. And then after that, I think it'll be up to chat. Why didn't I cancel the 1 plus x squared? Good question. May have missed a trick. Wouldn't be the first time. Why didn't I cancel the 1 plus x squared? I think I did. There's multiple times I cancelled factors. Oh well. Yeah, okay. Anything else from chat I want to read? I say not really. Shout out to Owen. Owen's doing a great job of moderating chat, running chat. I think I was also replying to some of the messages in chat. Good job, Owen. Here we go. Right, okay. Here's a multiple choice question. I would like ideas about how you approach this. Now, maybe you've already had a go at this because you had a look at the worksheet before the stream, which is encouraged. Or maybe you're seeing it for the first time now, which is also fine. I'm going to draw a picture, including things like y equals the square root of x, y equals x minus 2 I'm going to have to think about. I suppose it's going to be like this. Ooh, that was touch and go. So I might be interested in what this is, I might be interested in what this is, and you can see the x-axis in my picture. I'd quite like chat suggestions about how you get started with this. How do you work out this area? Because even with the discussion we just had about the difference between functions, that's not really what's going on here, because it's bounded by 3 things: a bit of the x-axis over here, a bit of a straight line, and a bit of curve. We're going to have 3 things instead of 2. and I work at New College. New College is one of the oldest colleges. It's a funny name for an old bit of building, but although some of our buildings and monuments are pretty old, we're teaching modern mathematics, of course, because all the colleges are teaching the same mathematics as each other. We send our students to lectures in the department. I'm in the department. I should be talking the other way around. I mostly work for the department. Thanks for the question, though. If we have questions, there is a contact in the YouTube description. It's also not a well-kept secret. There's a contact us button at the bottom of the MAT page, at the bottom of the MAT Live page. And the email address, I'll say it out loud, is undergraduate.admissions@maths.ox.ac.uk. That's quite hard to spell, I suppose, but you're welcome to use the link in the YouTube or anything to try and find undergraduate.admissions@maths.ox.ac.uk. My team is answering lots of questions at the moment about everything from people's A-levels and university applications to just everything. Right, okay, there's some suggestions in chat, let's have a look. And then there's a request for, what is this, question 1B of 2021, which is not on my sheet. Maybe. Shall I try and load it up while we're going? Now, I don't know if people are going to be saving more recent MAT tests. I think 2018 is the most recent ones I've used for the MAT Livestream resources. A very specific request. Right, science on brand. There we go. Yeah, people finding the intersections. People finding the. Why so many dots? Yeah, I know, it's lots of substructure, right? Maths.ox, because we're the maths department at Oxford. It's a long. It's like you're trying to get to the right university, the right department, the right office. It's like to put a lot of dots and everything. Being honest with that. Matthew says find the integral between root x between 0 and the intersection, meaning I think this one, which I've been coy about this, but it's 2, and this one is I think x equals 4. Yeah. Question at the top. Doesn't y equals root x span both? Nope. Root x is always positive. This is the difference between y squared equals x, which is the whole parabola that you're talking about, versus y equals square root x. Those are different. This square root symbol always means a positive number. We do that so that it's a function. Functions are supposed to take one input and give you one output, which this sideways parabola thing you're describing wouldn't be a function. The button on your calculator, we'd like it to return one answer. So even though there's this idea about sideways parabola, when people write the square root symbol, they always mean positive number. And then take away the triangle. Yes, perfect, good. I didn't keep up with your previous steps, but take away the triangle is a valid last step, right? So I like this description, which Matty was giving me, to sort of split it up. If you have a big problem, divide it, and they are interested in doing this thing on the left, and then maybe doing a version of the thing we were talking about on the right over here. But there's other people in chat who want to do something slightly different and then take away the triangle, right? So integrate everything underneath the curve up to 4 and then subtract the area of this triangle. And the area of a triangle you can find either using integration or using the formula for the area of a right-angled triangle. It's up to you. There you go. Right. Is it D? That's a good question, isn't it? It's a question equivalent to the question we're looking at. Is it D? I think it is D. Divide and conquer is the name of that technique for splitting it up. Here we are. Okay, so 2 ways to look at this. We could go 0 to 4 and subtract a triangle. Minus, what is that, half times base times height. Height of that triangle is square root of 4 is 2. Or we could do the integral from 0 to 2 of root x dx plus the integral from 2 to 4 of root x minus 2 from 2 to 4. And these things give you the same answer because you can combine together the parts of this that are about integrating root x. You can combine those together to give you this integral in the first case that we have in the first case. And this bit about integrating a straight line must give us the area of this triangle, the thing under the straight line. So if you want to use this formula we were talking about before, you could do that, or you can split it up. You can look for rectangles and triangles in the picture, and these are the same trick, so it's all good. If you like this kind of geometry puzzle of find the triangle, go for it. If you want to use a formula, go for it. Okay, can you integrate with respect to y? Yeah, I suppose if you know how. It's not something I expect you to know, and it's not that easy, so do it, but carefully if you know what you're doing. And particularly, you've got to rearrange this line, haven't you? It's not too bad, but you've got to rearrange this line so that you get something to integrate with respect to y. Yes, okay. Yes, square root x. People in chat talking about square root x only gives you positive numbers. Some people are, I think, interested in if this was a sort of sideways parabola, there would be another point where it crosses over here. Which is not what we're talking about. I think people learn lots of different things about square root x, and square root of x is one of those things where, well, the rule is it's always positive, and that is just a rule. Not very much would go wrong if we all agreed that square root symbol always meant a negative number. Maths probably wouldn't care, like the actual maths itself. Probably wouldn't care. We'd have to write some minus signs and some existing facts, but otherwise everything would be consistent. But the decision people have actually made, I'm afraid, is that square root x as a function always means positive value. How do you integrate square root of x? Great question. In chat they've rewritten it as x to 1/2. So the rule is add 1 to the power and divide by the new power. Don't forget the constant, which, I mean, I've done an indefinite integral over there. If you have limits, just plug in your limits and continue. But by rewriting root x as x to the 1/2, that's the first step. And then it's of the form x to the power of a minus 1. Aha, x to the power of a minus 1, we can integrate that. Good. People in chat are having a lot of fun of suggesting other stuff that you might need to know for math, and it's not very serious. Good, okay. Yeah, I sort of worry about, Rosie says as an April Fool's we should all take square roots to be negative. I suppose on the same day we can also agree that areas have to be negative, right? Just for fun. So if your integral gives you a positive answer, you have to go, oh no, and put a minus sign on it. We can all pretend that that's what we meant. It's one of those things where people it's just a little convention that we need to know. Okay. Somehow someone is still asking if you need to know the chain rule, and I'm not sure they're joking. So you don't need to know the chain rule for math. This is a very informative live stream, isn't it? It's only informative really on one point most of the time, but can't fault it. It's informing people about questions they want to know. Sorry, I'm still amused that people are asking questions. Right, sideways parabola makes me think there is this question about a sideways parabola. I said sideways parabola a lot, and I wasn't not sure if that's a thing people have met before. If not, here's a math question about them. Well, there's one normal parabola there, isn't it? Y equals x squared plus c. Nice, friendly. Seen these before. And then y squared equals x. I might call this a sideways parabola, because if y squared equals x, then y is plus or minus square root of x. And look how I have to include this plus or minus sign, because square root x always means the positive one. And for this to be a true fact, I need to include both. Isn't that horrible? I think somebody watching this is of the opinion that square root symbol can include both cases, but convention is that square root symbol always means a positive number. So if you want both, like I do here, I want both solutions. I want all of the points where y squared is x, which includes things like minus 3. which includes things like 3, minus 9. Unscripted fun. 9, unscripted fun. Can I get this right third time? Which includes things like 9, minus 3. Yes, that's an example of values of x and y such that y squared equals x when we talk about curve sketching or graph sketching next week. I would like to talk about sketching all of the points that satisfy an equation, which often for y equals f of x is just a matter of evaluating f of x for all the x values you can think of. But sometimes for like a graph of x squared plus y squared equals 1, what are you really doing there when you have x squared plus y squared equals 1? And you're supposed to draw that like this. What are you actually doing? I think you're colouring in all of the points x, y such that this rule is true. And you can invent more complicated rules. Fun to be had next week, I think. You can invent more complicated rules where that colouring in, it's just a line, right? A very thin colouring in puzzle. But you can colour in a more complicated region. Yes, right, good. Okay, do you always assume C is positive? Not always in life. In this question, it turns out that C is positive. Interesting. Okay. You're not allowed to have both, that is one to many. Yep. Functions are one to one. Functions are many to one, sorry. I always forget how many to one and one to one work. It's not language I often use. Functions are many to one. But the important fact about a function is that for each input it has exactly one output. I'm not even sure if many to one captures that correctly. I think I learned about many to one in GCSE IT, which is a very long time ago. Oh, we're trying to do the question as well. Sorry. Yes, people in the chat are trying to do the question. Look at them go. I just wanted to point at this sideways parabola thing, but if you're not actually do this question, right? It says you've got this fixed, this sideways one doesn't depend on C, but then you've got this one with a plus C in it. So I guess you're trying to move this up and down to get a point where it's just tangent. Yeah, there we go, a shared tangent. If you make C negative, maybe you can see that's not going to happen because where they cross, they're just going in totally different directions. You can do some inequalities to demonstrate that they're going in totally different directions, but negative values of C are not what I'm looking for this question. I was just thinking about like where it crosses, that's just yuck, it's not a tangent, it's going down versus going up. When I say inequalities there, I just mean check whether it's going up or down. Not even sure I'm going to calculate it. I've done a sketch. I've convinced myself. Right, yeah, so the sign, yes, it'll only be this case that I care about. And your algebra, if your algebra introduces extra solutions, which can happen, we've talked about it already, but if your algebra introduces extra solutions, it might correspond to some weird case down here where these things, the gradient might have the same square or something. And this happens all the time, right? That you have, you're trying to solve x minus 3 equals 0. Right, tricky one, here we go. X minus 3 equals 0. How do we solve that for x? Well, one thing you might try is squaring both sides. And if you square both sides, then you get this quadratic, and then you can go and solve this quadratic, right? Wait, what am I talking about? I don't know what I'm talking about. Yeah, I don't know what I'm talking about at all. Wait, I need to do a better example. Let's say you're trying to solve this equation, x minus 3 equals 1. Pretty tricky equation, can we do it? And your first step to solve this might be to square both sides. Chat's doing a great job of solving this question, so this is not just me messing around. And then rearrange, and then heroically remember the quadratic formula at just the right moment. What do I want here? Minus 4 and minus 2, I think. So x is 2 or x equals 4, but hang on a minute, only one of those actually works. In my original equation, only one of those works, right? 4 works. 2 doesn't work at all. 2 would give me minus 1 at the start, on the left. So this one is good. X equals 4 is correct. X equals 2 is a kind of misleading thing that's arrived. And when it comes from, when you square both sides, you got to be really careful. It was one of the bullet points for inequalities a couple of weeks ago. Last week for algebra. Squaring both sides could involve multiplying by a negative number. And multiplying inequalities by a negative number is really bad. Here, squaring is just really bad. Okay, what's going on in chat? Yeah, it's that way, but not both ways. Let's put that. So chat's got some advice about how you might do this question, and also has some advice about my algebra. You can go in a kind of one-way direction. Good. How do you differentiate from the actual answer and the misleading answer? The thing people do is to check them back in again. So if I've got these things down the end, and I think, wow, I've done all this work to calculate x equals 4 or x equals 2, I'm going to zoom in. Well, something you can do is to check. And I should go back up here. Big arrow. I should go back up here and actually look, well, did those actually work? If I plug in 2, I get, no, this didn't work. A different thing you can do is when you square, you can put a kind of warning sign to yourself to remember that you've introduced, potentially you've introduced solutions there. Essentially, the problem, if you like, is that this could have said -1 on the right. It could have said -1, and I'd have written the same thing in the second line, wouldn't I? Because when I square both sides, well, that could have said -1, or it could have said +1, and they'd both square to 1. So whichever one I was solving to start off with, I would now be solving this. And that's the ambiguity, that squaring takes positive numbers and negative numbers and returns the same thing. So in your equation, maybe you've got a delicate minus sign over here, but when you square, you'll get the same thing as if it wasn't there. So this step of checking is to really go back and check. Really, I guess what you're checking is, was there a minus sign right there? Or maybe a different one on the left or something, but was there a minus sign? Or was there not? Because either way, with this pretty stupid method, I'd have got the same equation just here. So I have to go and look at what I was actually trying to do. It's also good advice for life. If you think you've got down to a solution, go and check whether it actually solves the problem you were trying to solve and isn't just some artifact of your solution process. I've done that like I sound really bitter about something, I'm sorry. Cool. Yes, x minus 3 equals 0. Thank you. Anonymous in chat has managed to find a way to ruin the one that I was trying to ruin. Perfect. Love it a lot. Oh gosh, that's going to make me feel really ill afterwards. Okay. What are we doing? We're doing a bit of a question with some good advice about setting these things equal because they're supposed to go through at the same point, and also differentiating them and so making sure they have the same tangent. To differentiate them, I would probably work with y equals x to the 1/2 like this, because that's of the form x to the a, which I can differentiate. I don't really know how to work with y squared equals x using just facts from the maths, but if I rearrange it and work with this bit, y equals square root x. So to be clear, I'm just labelling this bit. Let's just avoid the issue by writing it somewhere else. This whole graph is y squared equals x. There we go. The top bit is y equals square root x. That's quite hard to label, but the top bit is y equals square root x. I'd work with that. And I can differentiate that using MAT. Then you get some equations, and hopefully, I mean, it's a bit tricky, but you've got to go and solve some equations and rearrange everything and do a lot of work. But once everything's fallen out, I think it works out to be B, I think. They're looking for the value of C as well, which is a bit annoying. I think along the way, my algebra finds the point where they intersect, but then I actually need to go back and do some rearranging to work out C, which is something to do with the value. What does that look like? Let's do a quick check. So equal gradient says that 2x should be equal to 1/2 x minus 1/2. Oh, so you can rearrange this and get 1/4. This is the part where I found out where it happens in terms of x. So x is 1/4, a bit of work with powers, the power of 2/3. Everything's positive, so I'm happy. And then the actual question asks for the value of c, so I actually need to go and work out y. I'm going to use this equation to work out y, and then I'm going to use this equation to work out c. I should count how many arrows I use in each one of these. It's quite a lot of arrows. Okay, so then my path to success now is y squared equals x, then c is y minus x squared. Yes, good. Work through it, you're stuck, okay, let's go. Chat says work through it, so I'm going to work through it. So I've differentiated y equals x squared plus c, and I've differentiated y equals x to the 1/2 to check that they've got the same gradient. I'm looking for this kind of magical point where they have the same value and the same gradient. To get there, I'll need the same gradient. So this tells me I'm interested in a particular value of x, a particular point where the magic happens, which is where the gradients match up. I should probably give this a name, really, because it's a special value of x. I'm not claiming this is true for all values of x. That would be mad. This is a straight line, and this is some sort of curve. So I'm looking, I suppose, if for some particular value of x. And that value of x, I can use some algebra to get this. So I get x is 1/4 to the 2/3, which is a rather pleasing combination of fractions and powers. And then my value for y is that square rooted, because I have that square root curve. So that's 1/4 to the 1/3. And then c is 1/4 to the 1/3 minus 1/4 to the 2/3. That's a bit of a mess, isn't it? That's not any of the options in the question, but maybe I noticed that I'm onto something because look at all those 4s and 3rds in option B. I'm not interested in any of the others really. I've got powers of 4, so maybe I noted that this is there a relationship here between these things? I suppose 4 to the 1/3, 4 to the 2/3. And in the option, the question looks like 4, confusingly, 4 to the 4/3. So maybe this is 1/4 as much. Maybe I've messed up. Maybe I can just simplify this. Where am I going with this? I've got really stuck. Huh. Happens to all of us, doesn't it? Why am I so stuck? What am I doing? I just kind of want this to be 1/4 or 3/4 of something. There's a 3 and a 4. There's 3/4 of something. 4 to the minus 1/3. Well, I got some minus signs in the wrong places. Oh, it's entirely possible I've got some minus signs in the wrong places. Reading backwards. No, I think I'm good on my minus signs. Is chat helping? Yes, chat's helping. What have I done? Why can't I simplify this fraction? I'm having real trouble. I'm going to rewrite it and see if I get a bright idea. Start messing around with it. This 4 to the 2/3 is 4. Oh, 4 to the 1/3. Take away 3/3. So I can put it like this. I think I'm just wrong. Oh, these are the, no. Yeah, I have messed up. 3 root x minus x squared. But I did that. That's this. That's that. Oh, wait. X squared. X squared. X squared. Thank you, Rosie. I have got the wrong powers. That's why I'm struggling. 4/3. Good, 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 good. Okay, phew. Right, okay. At which point I realised that is 1/4 of 1 over the 1/3, which is much nicer. It's much easier to get a factor of 3/4 out if you've got the right numbers. X squared up here. I wrote out x. Yeah, I misled myself by the difference between the x and the y squared. I thought I'd made them different, but I hadn't made them different enough. Cool, right. Thank you, chat. Right. Someone else in chat has got the same thing as me, and an anonymous person says you forgot to square your x value. Thank you, everyone. Good. I like to think I'd have got there too. Right. Oh, live for an hour and a half. Here we go. If you make a silly mistake like that and don't get the answer, would you recommend falling into the sunk cost fallacy and redoing or skipping the question? What would I do? To be honest, with all my factors of 4 and 1/3 and it's multiple choice, I'm 100% selecting B in that situation. The question is whether or not I'm convinced that I've got the right reasoning, but maybe this is me being a bit overconfident or something, but look at all these 4s and 1/3. I got some of the powers wrong, but I'm definitely picking B, and that is the right answer. Tee. Sunk cost fallacy, by the way, which is something going on in chat, is where you believe that I've written all of this out now, I've got to use it, which I'm not sure is a sunk cost. I think it's your maths, right? Well, for me, it's my maths on the screen. The skill I need to get better at, and this is hard, is I need to get better at fixing my own mistakes. It's really tough. Especially if I'm writing on a screen. But there we are. Good. Right. Okay. Okay. Right. What next? I think we should look at a longer question. We've got 2. Oh, look, I've got hints down here as well. Is one of the hints, don't get your powers wrong? No. I should add a hint for next year that says, hint, if you haven't squared x, try squaring x. Right, we've got 2 questions that we could look at. It's about 6:30 at time of recording. I put a couple on. So there's 2009 question 3 I picked. So I think this one, the actual integration part is not that bad. And then there's some inequalities that's a little bit harder to think about. So if we talk about this question, we might skip in there. And then I also picked out this really complicated question from 2015, which has lots of parts and asks about lots of bounds of integrals. So the question in chat is, are you using a mouse to write? If so, let's put it on screen. If so, that's really impressive. This is where I admit that my handwriting is that bad, even though I'm using a proper tablet. Using a proper graphics tablet, and it's still that bad. So I shouldn't really be making excuses, right? I've got the tech. Should be better. Oh dear. I always find it embarrassing when people realise that, no, it's not a mouse. He's just that bad. Right. Question 3. Where's this? Why are they? Why are they? Why are they? I'm really thrown by this chat comment. What does the chat comment say? What if I mod x be x if x is positive or 0 and negative x if x is negative? That's normal. That's just what it means, isn't it? These absolute value signs. So if it's positive, leave it alone. If it's 0, leave it alone. If it's negative, pop a minus sign on it. I want a positive answer. Good. Right. Oh, why the strict inequality? They're trying not to. Yeah, I know it doesn't. Okay, so they're trying to only define mod 0 once. That's pedantic, isn't it? Like, it would be fine if they said both. It would be true, but the normal thing to do when you're giving a definition of something is to only define it once. So I agree, they could make the other one of those inequalities at the top line. There we go. Good. So the request for 2009, question 3, part 4, which is very specific. So we're going to have a look at that. Okay, I think that's a good idea. We will get up to speed with the question though, just to check we're not missing anything important from the context. Let's read it. I was going to say read it together, but I won't know whether you're reading it or not. So what's actually going to happen is I'm going to read it, but maybe we're reading it together. Here we go. MAT 2009 question 3. For a positive whole number n, the function fnx is defined by, and then there's a definition, it says x to the power of 2n minus 1, subtract 1, and then square it. Part I says sketch the graph of y equals f2 of x, labelling where the graph meets the axis, easy peasy. We should just go and think about what that is when you plug in n equals 2. I think 2n minus 1 is 3. 2 times 2 is 4, minus 1 is 3, yes. So we'll have to think about whether this thing is positive or negative. X cubed minus 1, yeah, it really could be positive or negative, couldn't it? And we've got some squaring going on, which we've been talking about. It's all connected, isn't it? So that's part 1. And then part 2, think about making n a large positive number. So what happens to powers of x if you make n really large? Well, depends how big x is, doesn't it? If x is a large number, then large power of a large number is going to be huge. If x is a small number, like smaller than 1, between 0 and 1 maybe, then when you raise that to a big power, you get something quite small. So like a half of a half of a half is what 1/2 cubed means. 1/2 times 1/2 times 1/2, it gets smaller and smaller. That's the kind of difference, isn't it, between cubing 2 versus cubing 1/2. Do you get something that's bigger and bigger, or do you get something that's smaller and smaller? Right. How would you suggest trying to remember not to make silly mistakes like forgetting about squared? That's going to follow me around now, isn't it? Do you have any advice on being less of an idiot, like James is right now? It's going to follow me for the rest of the live stream. I can see it coming already. In my defense, the thing that I did, I got something wrong, but also kind of knew I'd got something wrong. Things didn't. I started messing around with the fractions to see if I could make it make sense, and I couldn't make it make sense, so I started looking back. I have the advantage of having chat, so I then looked at chat, and chat told me where to look. But realizing that you can't get any of the options, but you've definitely got a number, means it's time to start looking for mistakes. Right, okay, so we're sketching at the top. Part 3 is to actually do the integral, so I guess we would square it. Should we do that? Feels like we should probably do that. Determine this integral. Seems important. Okay, so we're going to do part 3. I need the definition of fn on screen, and I need the instruction for part 3 on screen. Split it. That's just about worked. So I'm being asked to do the integral from 0 to 1 of x to the power of 2n minus 1 squared. I'm going to lock in a little bit. There we go. Let's do the maths. There we go. That's nicer. Just make it a bit nicer for everyone. There we go. And possibly somebody in chat is currently typing that they would do some sort of sign substitution, maybe some sort of hyperbolic thing. Let's not bother. Let's just square this out. Because if we square this out, then, as we say in Scooby-Doo, let's find out what's really going on. It's polynomial. Oh, it's a polynomial. Polynomial with 3 terms in it. That's not bad at all. Because I can just add 1. Oh my goodness, right, here we go. So 2n minus 2. Don't forget the 2. Maybe I will forget the 2 a little bit. It cancels, doesn't it? Plus x on 0. Ooh, okay, 0 is easy to plug it in, so I'm going to get 1 over 4n minus 1 minus 1 over n minus 1 plus 1. Looks good. I'm playing on easy mode, so I'm going to go and check. Because if I've made, I suppose if I've got it wrong, chat's already telling me I've got it wrong. Oh, plus signs, n's, yeah. Yeah, I subtracted 1 instead of adding 1. It's going to be one of those days, isn't it? It's going to be one of those days. I can see chat going wild in the corner. They're enjoying this too much. Nailed it first time. Scooby-Doo's a show where they have, so for the person in chat, Scooby-Doo, let me just explain. Scooby-Doo's a show where they often have a villain disguised as a monster. So you look at it and you think, oh, a monster, right? You see this expression, you think, oh, yuck, monster. But then you remove the Halloween mask from the monster and you realise, this is just some guy. It's just some polynomial. I think about Scooby-Doo quite a lot when I'm making questions simpler, right? So you see the question, you think, oh, yuck, a monster. And then you think, wait a minute. It's just a polynomial. If you've never seen Scooby-Doo, then that's not going to be a good, reference point, is it? Question, Anonymous in chat's been very polite, actually. They said, did you integrate the middle one correctly? Answer, no. Ooh. Right, okay. How would the MAT change this year? MAT's actually not changed this year, has it? No, it's 2025. The MAT is essentially exactly the same as 2024. You can register a bit earlier, which is why I'm telling people to register compared to last year, but same format, same system, same syllabus, same MAT livestream, same mistakes. Right, okay. The request was actually for part 4, so we're going to have a look down at part 4, which says positive constants A and B are such that, and then it gives us some rule for this, and asks us to prove an inequality, and then explain why A is less than or equal to 3/4, which seems like quite a lot of work. But of course, we now know a fact about the thing on the left-hand side, because we just worked it out in part 3, so we should use that. So part 4, we know that the integral is this. And I suppose we have this new information, so I'm going to write it all out. 1 minus a over n plus b. And I'll put this bit in here as well for all n greater than or equal to 1. And we're asked to show that something. So I suppose we could start messing around with this, couldn't we? The +1 on both sides, the first thing I notice, and then my plan, I think, is to sort of multiply up. In the thing printed in the question, I can see n plus b on the left, and I can see 4n minus 1, n on the right. So I think my plan is to cancel these, do some multiplication, see what happens. Minus sign over here, I'll be careful with, because multiply by -1 flips inequalities. But actually I think I want this inequality to flip, don't I? It's this way around and I want it the other way around. So I'm going to multiply both sides by, what am I going to multiply by? I'm going to multiply by everything all at once. That's a bit ambitious, isn't it? Maybe I regret this. And a minus sign, why not? That's negative, because each term is positive and there's a minus sign at the front. So that looks like an insane thing to write down, but I have this motivation that I want to have fractions and I want to get rid of my fractions. I want an expression that has things like n plus b just hanging out there on the left. Of course, I don't know that the left and right are the same way around as I've got them, because inequality could be written the other way around, but I've just got a feeling that I can, if I do all this multiplication up, then I'll get something a bit like the thing in the question. I don't know I'm going to get exactly that, because, oh my goodness, here we go. Greater than sign because of the negative a, and then I need to write n, 4n minus 1. Is it working? It's looking pretty good. I've got the right hand side just where I wanted it, and on the left hand side I believe I've messed up some minus signs. Wouldn't be the first time today, would it? Because yeah, I've messed up with a minus sign exactly there and there, because I forgot I was multiplying by minus at the front. That time I got it without looking at chat. And also because I can compare with where I'm trying to go, which has 3n minus 1 coming up in a second. Oh, I guess this is becoming a bit of a clown show, isn't it? Just tripping over my algebra all the time. Deary me. Good, okay, I've got down to the thing printed in the question. But I suppose the extra bit there is to explain why a is less than or equal to 3/4. And I haven't really interacted yet with this idea that it's supposed to be true for all n greater than or equal to 1. I haven't really interacted with that at all. I suppose I used it a tiny bit to say, well, these things are supposed to be, you know, am I multiplying by a positive or a negative quantity? But if I actually want this to be true for all n greater than or equal to 1, I'm trying to think about what that means. So, you know, let's think critically. We're told that this thing is true for all n greater than or equal to 1. Let's have a brief moment of doubt, right? Could this really be true for all n greater than or equal to 1? I mean, the question says A and B are such that this happens, but I should be mildly suspicious that there are any such A and B such that that's true, right? Just because they've got capital letters and they're printed in black and white doesn't mean that there's any actual numbers that do this. And in particular, when I look on the left-hand side, what have I really got? It's another Scooby-Doo moment, right? Because this is a complicated expression, but really that's just a quadratic in terms of n. Right? It's 3n squared plus some stuff. And on the right, I've got a times something that looks like a quadratic in n as well. I'm going to multiply these out. I'll do 4a over there if I'm multiplying out properly. On the right, minus 4an. What does chat say? They're talking to on, good. And on the left, 3n squared minus n plus 3bn minus b. I'm going to put versus in the middle like it's a fight. And that's quite suspicious because I've got a quadratic over here with a 3 in it, and I've got a quadratic over here with a 4 in it. I kind of think this one's larger. Oh, I suppose unless there's the 3 and the 4. And part of this argument is me trying to work towards having an a 3 and a 4. Where can I see those things? Answer at the front of each expression. That can only be the case. I'll say for large n, if a is, which way around do I want it? I want this one to be small, so I want a to be small. I might write that out as 4a less than or equal to 3, therefore a less than or equal to 3 over 4. Do I mean minus an, not minus 4an? Yep, I've put 4's in the wrong places, but then I've ignored that term. Thank you. Good. Anything else? Minus b on the end? Yeah, left-hand side's good. Good, okay. Yes, and there's things going as n is really large. Right, expansion on the right-hand side. Yes, don't think I did it right, did I? Right, okay. There's another part of this, which is to ask if a is equal to 3 over 4, the last part of the question, which doesn't mean it's the hardest part of the question, it just means it's also there. If a is actually equal to 3 over 4, then what can you tell me about b? So we should say, I suppose, if a is equal to 3 over 4, then this thing simplifies quite a lot more because the n squared terms will cancel. So if a is actually equal to 3 over 4, then we still need to have 3b minus 1 times n minus b on the left. That's still what I've got. I'm cancelling off this 3n squared. I still want this to be greater than or equal to minus 3/4 n. It's not obvious that's going to happen either, right? It depends on b. For different values of b, I get different lines on the left. They've got different y-intercepts and they've got different gradients. I want this line on the left to be larger for all positive integer values of n. So it better start, I kind of need it to grow faster, otherwise it will eventually be smaller than, what am I talking about? Minus 3 over 4n. Am I happy with that? Am I happy with that? I'm not sure. Yeah, I think I'm happy. Sorry, they're both decreasing functions, but that's perhaps depending on b, but I think I'm all right. You can make b quite small and still have this be a decreasing function, that just happens to be larger. Double check. Still need this. Good. Yeah, so we should check n equals 1, but we should also think a little bit about, we should check n equals 1, which is what, who's this in chat? Rosie again. Says in chat, we should check n equals 1. Should maybe draw a picture, think about what's going on for large n as well, just in case that gives you another kind of limit on b. Those are the places where I think it might happen. Once you've checked 2 places, straight lines. Oh, no, that's not true, is it? I was going to say, once you've checked 2 points, which of these lines is larger, you're done. But no, I've thought of a case where the lines are getting closer slowly and will eventually cross over. You need to make sure that the one on the left has got a greater gradient and that the value when n equals 1 is already ahead at n equals 1. there's kind of all these different cases, right? You've got minus 3/4 n, which looks like this over here, minus 3/4 n. And then you've got all these different cases for values of b, which I guess maybe it could be like a line that has a steeper gradient, but starts way down here, so it's terrible. Or it could be steeper gradient, but starts up here, which is what we want. Or it could be, you know, starting up here, but more negative gradient, so it'll end up crossing over and being less. Different things that could happen. This might be a fun one to explore. Maybe if you put a more interesting line on the right hand side, so 2x plus 1 or something on the right hand side, and then ask for which lines mx plus c, when is it true that mx plus c is greater than or equal to 2x plus 1 for all positive x? Let's go. When is it true that this line on the left, mx plus c, beats 2x plus 1 for all positive x? Yeah. Good. Okay. Yes. So we could look at particular values of x, but I think we should also worry about whether m is greater than or equal to 2. The value of c seems important for where it starts. When x is let's put that in. When x is equal to 0, but then the value of m seems important as well. Yeah. Cool. Okay. Let's look at the values. If, for example, says chat, this question, part 4, is 7 marks in total, and you can only either show that but not explain why. Do you still get some of the marks? Yes. The long questions have partial credit. That's what we call partial credit. Is what we call it for getting some but not all of the marks for particular parts. You can also get marks for later parts, even if you didn't get marks in previous parts. So in this question, if you can't explain why a is less than or equal to 3 over 4, but you can talk about what's going on when a equals 3 over 4, then you can get some marks for that part. Even if you didn't do the previous part, they're marked separately by the same person. But you can gain marks for doing true things, correct things, explaining things, wherever you are in the question. For the long questions, you get marks for, I suppose we can call it working, right? I'm going to call it marks for work, like you're doing stuff. And the stuff is true or correct, I suppose, before anybody asks. But you get marks for that sort of work. I'm not going to say marks for working out, because I think that will make people ask again about typesetting symbols and showing they're working, which is not really the spirit of the long questions that we're going to do. This question is from 2009, when people answered everything on paper, and answering on paper we did questions where you have to draw integral signs with a pen and sort of write pages of mathematics, and it's a bit sad that we can't do that in 2025 because we can't collect in paper from everybody. You get something to write on in the test centre, but we don't have the ability to collect it in, which means that we've designed these long questions that you can answer with a keyboard instead. Why did we switch to computers? Yeah, so bit of a long story, but we used to have an agreement with some people who could run tests on paper, and they no longer run any tests at all. So we're no longer working with them because they're not doing this at all. And we've got this agreement to do it with some people on computers. It's better than nothing. Quite a lot better than nothing. Plus 25 multiple choice questions, which haven't changed in spirit at all. Trees as well. It was quite a lot of paper. There's the question that I thought we'd almost avoided. You don't need to learn LaTeX or MathJax or any of those things. If you did, then I would probably have to teach people. I'm not teaching anyone how to do the symbol for the sandwich letter. Is the provision to use a tablet like for writing digitally like yours? No. It's a regulated test centre. You can't take your own tech in. Really sorry. Also, can you use this for typing? Should I be using this for typing? I don't know about that. Sorry, same sort of experience for everyone. Okay, it's almost 7 o'clock. What should we do? Let's put the other question on the screen, just a little bit. I'm quite proud of us there. We got through most of a long question. There's the hints for this question. And that's the extension of this question. Oh, let's do this extension. Yeah, let's not put the other one on screen. We've done enough. We've done enough. Let's put the extension on the screen. That's more fun. And I'm going to talk to chat a little bit. If you're watching the replay, then probably not much more maths is going to happen on screen. But just for 5 minutes, I'm going to try and keep up with chat. Yeah, you get something to write on. It's kind of more like a whiteboard than like writing on paper. That's because it's reusable. They collect it off you and wipe it clean to use it again in the future. But you get something to write on. Good. Okay. Right. Okay. Some incorrect facts about clay tablets. Ginger Biscuit wants to know whether my t-shirt has arrived yet. My t-shirt has not arrived. I'm trying to get some maths printed on a t-shirt so I can wear a mathsy t-shirt for a conference. Mentioned it on a different thing. Hasn't arrived yet, but I'm looking forward to it. I should double check all the maths that I've put on this t-shirt. Maybe I'll wear it on this show at some point if I can ever get this t-shirt. Right, according to this, they get erasable whiteboards. Yeah, is that what they're calling them? Erasable whiteboards. Yeah. It's sort of a bit weird. It's not quite the case that, yeah, well, anyway, you get this thing to write on, which is good for rough work for multiple choice questions. For the longer questions, I think pretty much you might scribble some stuff down on the whiteboard, but you also might just think and then type. What advice do you have on timings per question? You can do whatever you like, so there's no rules on timings. You have a time limit for the whole test, but there's no rules about how much time you have to spend on each section, which is a thing that other people do. We don't do that. I think you'll probably spend a few minutes on each multiple choice question, and you'll try to leave a chunk of time for the longer questions. There's a kind of navigator button. When we launch a sample test, you'll see this kind of navigator button so that you can, if you like, jump to the long questions and have a go at those first. That's up to you. But it's up to, there's quite a lot of things to do, so you might spend a few minutes on each multiple choice question and then go and look at the long questions as well, or you might do it the other way around. But personally, I wouldn't set a timer for myself. I would try and make sure I'd had a look at everything during the test, and I'd do it however I was feeling on the day, I think. But that's just me. You might want to set yourself rules. There is a timer on screen while you're doing it if you want to use that. I think you can hide the timer, but I'm not sure. I think you can hide the timer. We'll have a go with the practice test. There's a sample of what the testing environment looks like that's going to go live pretty soon. We'll tell you about it next week, if it's live next week. It's also the open days next week. That's exciting. STEP is significantly harder than MAT. Okay, and since this is easier, do the Oxford admissions focus on other metrics? No. MAT is taken much earlier in the year than STEP. So if we set STEP in October, then some people wouldn't have learnt the right maths to do it yet, so it would be completely useless and a bit unfair. MAT is much easier if you hold the two side by side. It's taken by people who are almost a year younger and who are being tested on less maths. We use it quite a lot in our admissions process because it's really good at distinguishing between people who are good at solving unfamiliar problems and people who have really got fluent and understand their A-level maths. It's very helpful for telling our applicants apart. The question you should be asking is, what would happen if Cambridge applicants also took the MAT, and what would happen if Oxford applicants also took the STEP? But we will never know because the university is making anybody do that. Okay. Can you flip through the questions like a piece of paper, or do you have to click? So there's a navigator button which lets you jump to a particular question. If you know that you want to do question 17 first, you can jump to it if you want to, or you can click next question 16 times if you like. Right, it's a question about the extension, which is on screen underneath, which is about exploring other relationships. And then there's a horrible part to try and sketch this thing that we've been working with. Yeah, so no, hang on. So I think you're going to be, okay, I think you're going to be doing a bit of stuff on whiteboard and then selecting a multiple choice option. Selecting multiple choice options is really fast. You just click on the one that matches the thing that you got on your whiteboard. Who knows, maybe some of them you can do without writing much at all. And then separately, there are long questions where you're typing. And that's different because I think for those questions, you'll be doing much less stuff on a whiteboard and much more typing your answer. That's the kind of mode that we've got here. Kind of multiple choice questions where you might scribble something down, do a bit of a calculation, and then tell me what answer you've got by clicking on it. And long questions where you'll want me to see more of your thought process and you'll type more of your reasoning. But that's not much of I don't think there should be any questions where you're typing something up. Yeah, that's because that's a bit like doing it twice. So people asking about typesetting and LaTeX stuff, that's kind of really not the idea about what we're doing there. Computers provided in the test centres. People are going to take this test in Pearson VUE test centres. If you're in the UK, these are also test centres that are used for driving tests. So if you've done your driving test, you might have already seen a Pearson VUE test centre. They have standardised equipment around the world because we have people taking this all over the place, as I know from people in chat saying where they're watching from. Good, okay. Anything else? What do I think of the rule that you can only apply to either Cambridge or Oxford? I think it makes admissions easier for Cambridge and Oxford, because if you could apply to both, then I think a lot of people would apply to both. So I think it makes admissions much easier that we should get people to choose. If you could apply to both, you might then get offers from both, and then you might have to choose anyway. You can't go to both simultaneously. So I think it's kind of fair to ask people to choose between the two. Right, okay. Don't have time to drive, need to grind maths. Okay. Maybe that anonymous person will be amused to hear that I can't drive because I've been grinding maths for so many years. What's the curriculum for maths and CS? Do you learn both or just the intersection? Bit of both. Not the union, not all of both on the Venn diagram, but also not just the intersection on the Venn diagram. So, if I got a sketch. Maths content, CS content. So there's like this world of math content, and there's some like cool stuff that you're probably really interested in that's both, right? Like kind of algorithm design and questions about order of operations and all sorts of. I don't mean order of operations. I mean the complexity, like how much computation you're doing. And so if you do maths degree, you'll do this stuff. We have options of doing all of this stuff. If you do a CS degree, you're doing the stuff in that bit of the Venn diagram. And then the interesting one, perhaps, is if you're doing maths and CS, you have access to something like this at Oxford, which is stuff in the intersection that you're definitely excited about. Some maths content that you wouldn't do in a CS degree, and some CS content that you wouldn't do in a maths degree. But it's not just the intersection, and it's also not the whole union. There are, if you care, there are things out here on differential equations and applied mathematics, and there are things out here that I know much less about. Save. Good. Do you plan to be around your college on the open day? If you're coming to the open day next week, I plan to be in the department where I'm organising. What's my job? Where I'm organising the open day for the maths department. So you'll see maybe some maths talks in the open day that we've organised. So I'll be around in the department. If you're coming to the open day next week, feel free to come and say hi. Although there are thousands of people in Oxford, and I'm sure lots of people will want to say hi to the maths department at some point. We've got a Maths at Oxford talk which has got information about applying. It's going to have an advert for the MAT livestream, and you will feel, I don't know, happy that you've already found the MAT livestream, I hope. Right, okay, I think we're wrapping up. It's 7 o'clock, which is when I told Owen that Owen could stop being in Slido. You've done great, Owen, if you're still watching. You can email for maths questions. We might not be so fast to answer maths questions, but if you send maths questions into the email inbox, then we often do get around to either answering them or telling you why we can't. Good job. Right. How to get a good idea of the colleges. Lots of them have got really good websites. Lots of them have got pictures online, and at the end of the day, they have access to the same maths degree. So whichever college you study at, you'd get the same maths. I really care about the maths content. I do like the colleges. They're all great. Right, good. Okay, take care, everyone. Possibly see some of you at the open day. Possibly see some of you around. But maybe I'll see you next week for another episode of the Oxford MAT Livestream. How do I end the show? There we go. I've made mistakes. We've all learned about areas under curves. We've learned about areas inside Venn diagrams. We've learned about gradients of lines and inequalities. I think this was a really good demonstration of things linking together. That we did some integration, poorly on my part, and then we did some inequalities. A lot of these math questions combine together separate topics, and at the moment we're working one topic at a time, episode to episode, and maybe it's in a few episodes time we'll start to have more of a linking together kind of sense of what's going on. Right, good. I'll see you in 166 hours for another episode of the Oxford MAT Livestream. Until then, have a nice evening, have a good weekend. Bye. When I press the button?